So the next one is AAS congruence theorem. So you might be thinking it's just the same as the previous one because we have two angles and one side. But actually, the side that we are talking about here is the non-included side. So in the previous item or in the previous postulate, we are talking about the included side. So here, we are talking about the non-included side. So if you have two triangles, let's say for example, ABC and DEF. So we need two congruent angles. So let's say angle A is congruent to angle B, and let's say angle C is congruent to angle F. We are talking about the non-included side, so we cannot use AC and DF this time. So instead, we can use AB or BC, it's up to you, but I'll just use AB for the sake of discussion, and it's congruent to DE. Now, if you see the two triangles are congruent, or that if you see that there are two pairs of congruent angles and a pair of non-included sides are also congruent, then you can already say that the two triangles are congruent. So ABC is congruent to triangle DEF. And lastly, we have the HL. So what's HL? HL is hypotenuse leg congruence theorem. So this only applies for right triangles. So if the triangle that you can see in the given is not right, then definitely you will drop out HL congruence theorem from your choices because this only applies for right triangles. Now, what's the hypotenuse? So the hypotenuse is the side across your right angle. So in this case, your right angle is here. So your hypotenuse is the one across it. So your hypotenuse is AB. And then we call the other two sides the legs. So AC and BC are your legs. So if there are two triangles and the hypotenuse of one triangle is congruent to the hypotenuse of another triangle, and one leg is congruent to the leg of the other triangle, then the two triangles are congruent. So let's say for example, we have here triangle DEF. So if side DE is congruent to side AB, so they are both hypotenuse, right? And let's say AC is congruent to DE, then we can conclude right away that the two triangles are congruent by HL congruence